Implicit differentiation, again, that's a time where we have a function that's not a function of y or x. It's a function of x and y's together. This example here is an example of a circle. It talks about how you could solve for y, and then when you solve for y, you'd have two functions that would represent the top and the bottom half of the circle. And then you could differentiate those separately, and that would essentially give you two separate spots. But you'd have to figure out, okay, which one has the appropriate range that I want, which one's a positive, which one's a negative, etc. Okay, so it just gets you into kind of a more difficult situation of trying to figure out how can I differentiate that. Well, the thing I want to show you in terms of differentiating this with the Lebanese is that we are taking d of dx. D of dx does mean derivative with respect to x. That's what we usually do with everything. But the thing I didn't really say yesterday that I want to say, we can still write y prime. That's fine. I'm going to write y prime all the time as well. That's easier for notation. Okay? But this is what I want to show you. If we do d over dx everything, okay, we d over dx everything. Everything's good except for this spot, because we have a y. So what happens is we use that to our advantage. That's where the y prime comes into play. Because we can do d of dx of x squared, that's 2x. We want to do what to a y? Not d of dx, but d of dy. And so we're going to write this as d over dy y squared, but then to balance it, we write that. Because look at these fraction y's. The dy's cancel, so you're really doing d over dx. So that's why you get away with doing the y's and the x's. That's why the y prime, this is our y prime, right? That's where that comes from. Okay, and I didn't really lay that out very well yesterday, so I wanted to show you that today. That's why it looks like we're doing different things to different pieces, but we're not. We're doing the same thing the way that helps us. Okay, because we want to derive with respect to y. And then the dy dx makes that cancel, which is still the d over dx. Okay, so then that's 0. That'd be that. Then we'd minus the 2x and we divide the 2y yesterday, right? Because we're solving for y prime. Remember, the equation of the tangent line is defined by that. Y prime does. So when we're doing this, we're solving for dy dx, we're solving for y prime. So by making that adjustment, by doing this, is actually one thing that really frustrated me in university was I wish I understood this, because I kind of just wrote it down a few times, that this is helping me. I'm taking the derivative in the way I want, and I'm gaining the thing I want to solve for. And so it makes a lot of sense when you look at it in that perspective. Okay, is there any questions on that? Does that make sense at all, hopefully? A little bit? For the video, I will solve it. So y prime is negative 2x over 2y, which is negative x over y. And then if we want to do at the point negative 4, 3, we plug in negative 4 and 3, which we did yesterday. We got negative 4 thirds, or excuse me, positive 4 thirds. So our tangent slope ended up being 4 thirds yesterday. And then I'll let you guys can do the equation and line stuff, no problem. You guys plug in the point and solve for b. Okay? So I'll leave that. Okay, so then with perspective to this guy, where we had to use the product rule, it still has the same thing. We're still going to d over dx everything. Okay, so let's go ahead and do that now. So I'm going to just derivative of this, 10x4. Derivative of this is the product rule. So that's where you got to say, okay, I need to do the product rule here. So I have to do first derivative of the second. So remember, we talked about when you're doing y, you're doing the derivative of the y, we do need a d over dx it, but that's again, we're going to d over dy. Sorry, I'm out of room here. For this single y, it'd be d over dy dx again. It's again to make it balanced for us. You don't have to write things in Lebanese. I'm just showing you what's happening in terms of Lebanese because it gives you the actual canceling of how you're still doing d over dx. So the derivative of y with respect to y is just 1. So that's what I messed up yesterday. Remember I kept the y there on accident? And it's just y prime. Because the derivative of this is just 1, y prime. So that's what it would be. First derivative second would just be y prime. Okay? Second derivative first, y derivative of the first is 4x cubed plus 5y 4y prime equals 0. If you're again, I'm not going to write the dy dx's all the time, but you're welcome to ask if you want any clarification on that, no problem. So at this point, I talked about yesterday, we want to isolate the y primes and then solve. So we want to move this away and move this away because they don't have y primes. So we have x4 y prime plus 5y4 y prime equals 10x4, a negative 10x4. If I minus it, and then a negative, I'm going to write the x first, 4x cubed y. Pull the y prime out here. And this is what we're dividing over. That's your derivative using implicit differentiation. Okay? So on this one, again, we kind of did already, so I'm not going to go through it further, but we plug the point in 1 and 2 for our x and our y's. We get a value. When we did that, we got negative 2/9. Okay, when you plug that in, so negative 2/9 was our slope. It just asked for the slope, not the equation, so that was all for that one. Okay? All right, so let's do the harder one here to finish up 2/7, and then we'll go into 2/8. Okay, so find y prime of x squared plus root y equals x squared y cubed plus 5. So we have two sides here. Okay, so we're still going to do everything like we just talked about. We're going to do d over dx of everything, and when we have a y, we're going to do the y prime. Okay, so kind of if you want to get rid of this, we can write that as what? Yeah, it's the 1/2. That can help us a little bit here. Okay. So, derivative of this, 2x, no problem. Derivative of this is going to be 1 over 2 root y, y prime. You still have that dy dx there, right? Because you're hitting a y. Equals, you can write 1/2. I don't know, I just had my notes. Square root.
But like, what are we supposed to write about?
Like, it doesn't matter. Maybe because if I'm having you plug it in, like if you do something with the 1/2 and square root, it's the same answer, so you're not going to get it wrong. So I wouldn't take off points at all. Okay. Here we go. First, derivative of second, 3y squared y prime. Plus second, derivative first, 2x. And then I don't have to put plus 0, the 5's gone, right? It's a constant. So here's the point where you've taken the derivative. You need to go and just think about where are my y primes. I need to get them together. Okay? So I would probably, just because I don't like messing or moving fractions much, I would probably move him over here and the 2x over here is what I would do. Okay, so that's what I'm going to do, I guess. Okay, so I'm going to minus this over here. Minus this over here. So we have technically I could put the y prime up here. Whoa, big eraser. I'm just going to put it on top just so it's one thing. So I move that. I have that. Okay, so now we're going to pull the y prime out. And we're going to divide that over. Okay, on my notes, you can pull the 2x out. Doesn't really do anything, but you could pull it out just so it makes things easier to plug in. Okay, so if like I pull that 2x out up top, like I could write it all the way simplified as 2x times y cubed minus 1 all over this. Just makes it a little easier to plug things in. And that is it. Okay, that's the derivative. Okay. All right.